So let's solve some calculation on frictional force. Okay, so the first question we are going to look at, number one, is number one question said they gave us a body this way at 30 degrees, and that body is 20 kg. Okay, there is a force that is acting on that body, 40 newton. Okay, this is the diagram they gave us. They now said a body of mass 20 kg slides down on a plane inclined at 30 degrees to the horizontal, okay, as shown above. If a constant resistant force of 40 newton acts on the body, its acceleration down the plane is dash. So we should find the acceleration down the plane. Okay, there is a force here. This force is called the applied force, and we know that the force that will make this body to move should be what? The applied force minus the frictional force. Okay, and so normally formula for applied for the formula for moving force is what? Ma is equal to what? Formula for applied force. If I'm applying this thing downward like this, for this thing to come down means that this line, this plane has to go up. So applied force is acting vertically. So, and if it's acting vertically, it's going away from this. And if you look at ASTC, away from the angle, use sine. So it's going to be what? Mg sine theta. Okay, minus the frictional force they gave us at 40. So what do we have now? My M is what? 20 times A is equal to what? 20 times 10 sine 30. Then minus what? 40. So I'm having what? 20A is equal to what? 100 minus 40. Okay, this is 200 divided by 2 because sine 30 is half. So half of 200 is 100. So I'm having that what? 20A is equal to 60. Therefore, A is equal to 60 over 20, which is what? 3 meters per second square. As simple as that. Number two. Number two says a stationary block of mass. They gave us the mass. A stationary block of mass 5 kg, okay, is set in a motion by a force of 60 newton. So the moving force is equal to 60 newton. Okay, they now say the object attains a speed of 9 km per hour in t second. Find t. Very, very simple. We know that our moving force is equal to what? Ma. So therefore 60 is equal to what? 5 times A. So A will now be what? 60 divided by 5, which is 30. That is 60 divided by this is 12. So I'm having 12 meters per second square. Okay, but I know that acceleration is velocity over time. Okay, so they gave us the velocity. They say at velocity of 9 meters per second. So what do we have now? The time will now be what? Velocity divided by acceleration, which is what? 9 divided by 12, which is what? 3 over 4 seconds. Okay, as simple as that. Number 3. Number 3 gave us a plane like this. Three kg, 6 kg. Okay, they gave us, and they said that this block is not smooth. Okay, so they said that two blocks of masses 3 kg and 6 kg are connected by a light inextensible string which passes over a smooth pulley as shown in the diagram above. Assuming the 6 kg mass is sitting on a smooth surface. If it's sitting on a smooth surface, it means no frictional force affecting it. Okay, it's sitting on a smooth surface. Then calculate the acceleration of the body. Now, for the 6 kg, normally we know that the moving force is equal to what? The applied force minus the frictional force. okay, but there's no frictional force here. The only thing we have here is an applied force, and this applied force is going this way, okay, and this one coming this way. This is the frictional force, the frictional force. So the frictional force here, let me say there is no frictional force here. What we have here is just the applied force. This is the applied force, okay. So the only thing we have here is this. So this one should be out for this. So I'm having only these two. So I'm having that what? 6 times A, the acceleration, is equal to what? The applied force or the frictional force. Let me call it the applied force. Okay? Then for the 3 kg, okay, I'm going to have that what? That the force that will make this thing to move should be what? The applied force minus the frictional force. In fact, let me call this the frictional force. Okay? I want exactly any tension, or let me call it tension. Let me not use the frictional force. Let me use the word tension. Okay, the tension here, because there is no frictional force, is a tension. So the tension here should be equal to the tension here. Okay, but the tension here is called the frictional force. Okay, but the tension here is the normal tension. Because this is smooth, there is no frictional force. Okay, and since it is smooth, nothing is pushing it this way. Everything is going on the same direction. Everything is going on the same direction. So I'm having that this is MA. MA. I know that you know the formula for this MA. So MA is what? 3 times A is equal to what? The frictional force here, sorry, the applied force here is the weight of this body, which is what? Mg. Okay, let me just write it. This one is MA. The weight of this body acts downward. Okay, so that is the applied force here, while I still have my tension. So I'm going to have that what? 3A is equal to what? 30 minus T. But I know that my T is 6A, so I'm going to have that 3A is equal to what? 30 minus 6A. So therefore, 3A plus 6A is equal to 30. So therefore, 9A is equal to 30, and my A will now be. So this will now make my A to be what? 30 divided by 9, which is what? 10 over 3 meter per second square. So that is what? The acceleration of that body. So the next question, number 4. Number 4 said, calculate they said if the coefficient of static friction in the question above is 0.5, okay, we should still calculate the acceleration of the body. Okay, we should still calculate the acceleration of the body. We know that coefficient of static friction is equal to what? Frictional force all over what? The normal reaction. The normal reaction. Okay, and the frictional force is equal to what? The frictional force will now be cross multiplied. Coefficient of static friction times the normal reaction, and coefficient of static friction here is 0.5 times the normal reaction is, you know that the one that will have coefficient of static friction is the one on this plane and not this one, the one on this plane. So I'm going to use what? The normal reaction is mg, okay, which is what? 0.5 times 6 times 10. Okay, so I'm going to have 30. The coefficient of the frictional force here is 30. So but I know that force is equal to ma, which is equal to 30. So my m is 6 times a is equal to 30. Therefore my a will now be equal to what? 30 divided by 6, which is what? 5 meter per second square. Okay, so that is that. So let us continue. Question number 5. Question number 5 gave us something like this. 30 3 kg it's too long, don't know how to draw. So I have 2 kg. Okay, so the question now said a 2 kg mass on a smooth inclined plane is connected over a smooth pulley to 3 kg mass, okay, as shown in the diagram above. Calculate the acceleration of the body. Okay, so this is a smooth inclined plane. So if it's a smooth inclined plane like the other one, frictional force does not affect it. The only thing we have here is the tension. The only thing we have here is what? The tension. Okay, and we have the same tension here. Why this one acts downward, the weight of the body. Okay, normally. So we are going to say that what? That the moving force here is equal to the tension. I hope you still remember, because this is the frictional. What is it called? Okay, let's talk about for 3 kg mass. For 2 kg mass, sorry. For 2 kg mass, I'm going to have that what? That the frictional force, okay, that the moving force is equal to, in fact, there is a force that is moving this thing downwards here. Yes, there is a force that is moving it downwards here. But this is a smooth plane. So since it's a smooth plane, the frictional force does not affect it. So everything goes together. So since everything is going together, I think I'm going to be having, what I think is I'm going to be having that this is the applied force, applied force plus the tension. Okay, applied force plus the tension. So I'm going to have that the 2 kg mass. So this is MA. MA is equal to what? The applied force here should be what? mg sine theta. I hope you know why it is sine. If you're applying this thing here, this is a vertical force, okay? For this thing to slide down, this one will go up, so it's vertically. And vertical is what? ASTC. Away from the angle sine, so that's why I use sine, okay? Plus the tension. So I'm going to have that what? 2A is equal to what? 2G. I want to use G because the option there has G. 2G sine 30, okay, plus T. So what do I have now? That my T, okay, that 2A is equal to, this is half time to cancel, so I'm having only G here, plus T. So my tension is what? G minus 2A, okay? My tension is G minus 2A. My tension is G minus 2A. Okay, so let us do for 3 kg mass. For 3 kg mass, for 3 kg. Now for 3 kg mass, I'm going to have two opposing forces. So I'm having that the moving force here should be equal to what? The applied force minus the frictional force, because they are opposite each other. In fact, this one is supposed to be acting in the same direction. Why? Because this thing is a smooth plane. Okay, it will just go fair. So what do I have now? MA is equal to what? This is the weight of the body, mg. This is the weight of the body. That is the applied force. It is pulling it down minus the frictional force. Okay, so I'm going to have that 3A is equal to what? 3G minus FR. So, or tension. Let me call it tension. This is the tension. Okay, so if I collect like terms, in fact, let me carry my tension and put here so that I can get my A. So I'm having that 3A is equal to 3G minus, my tension is what? G minus 2A. So I'm going to have that what? That 3A is equal to, is it? 3A is equal to 3G minus G, okay, plus 2A. So what do we have now? Okay, in fact, since this thing is a smooth plane, this one will be acting, in fact, this one is supposed to be acting in the same direction. Supposed to be acting in the same direction. So let me have plus here. Let me have plus here. So I'm going to have plus this minus this, okay? So what do I have now? What am I having? Okay, so this collect items to have 3A plus 2A is equal to what? 3G plus G. So I'm having that what? 5A is equal to what? 3G. So my 4G. So my A is equal to 4G over 5. 4G over 5. Okay? So let me check. Okay, that 2A. Did I make mistake here? That the tension is equal to, sorry, tension staying alone. Okay, G is the one moving. Sorry, I made mistake here. G is the one moving. So I'm going to have that tension is equal to 2A minus G. G is the one moving. 2A minus G. So that was what was confusing me. So it's going to be 2A minus G. So I'm going to have that. So this time this will give you minus 2A. This time this will give you. Am I getting it? 2A minus plus G. So I'm going to have. I'm having that the tension, which is 2A minus G. Okay. So I'm going to have that 3A plus 2A is equal to 4G. So therefore, I'm going to have that what? 5A is equal to 4G. So my A is what? 4G over 5. 4G over 5. For the 2 kg mass. Okay. So that is that. So the next question. Number 32. They said a body of mass 40 gram. Is that